Look up at the sky tonight and imagine a second moon hanging right next to the one we're used to. Not a small star, not a distant planet, a full moon, close in size to our current one, glowing with nearly the same brightness. This idea isn't as far from reality as you might think. Other planets in our solar system, like Jupiter and Saturn, have dozens of moons each. So the question we're answering today is, if Earth actually had a second moon, what would change about our lives and about the planet itself? And the answer is far more complex and far more dangerous than you'd expect. The first and simplest change would be the night sky itself. Assuming the second moon sits in a different orbit than the first, there would be nights lit up by two moons at once, and other nights where only one moon is visible while the other sits on the far side of Earth or below the horizon. True, complete darkness, something we rely on for stargazing, and something countless species depend on for their biological clocks, would become far rarer. Countless organisms on Earth, from sea turtles to nocturnal insects, use moonlight levels to regulate behavior: reproduction, migration, hunting. A second moon would fundamentally disrupt that rhythm. Our current moon is the primary driver of Earth's tides, thanks to its gravitational pull on the oceans. A second moon means an additional source of gravitational pull, which would make tides far more complex than the simple pattern we're used to. Instead of just 2 tide cycles a day, we could end up with overlapping patterns, sometimes reinforcing each other, sometimes canceling out, depending on where each moon sits relative to Earth and the Sun at any given moment. Certain coastal regions could see dramatically larger tidal swings than normal at specific times, affecting navigation, fishing, and coastal cities built around a relatively predictable tidal pattern. With 2 moons, eclipses wouldn't just become more common, they'd become far more complex. You could see a partial eclipse caused by one moon while the other remains fully visible, or in extremely rare cases, both moons could cross paths in the same region of sky at once, creating a compound phenomenon we have zero historical experience with. Also, since each moon would likely sit at a different distance from Earth, their apparent size in the sky would differ. The perfect total solar eclipse we experience today, where the moon exactly covers the sun's disk, could actually become rarer, since the odds of either moon being at exactly the right distance and angle would drop. Here's where we move well beyond visual changes into something far more serious. Our current moon does more than light up our nights. It plays a critical role in stabilizing Earth's axial tilt, about 23.5 degrees, over millions of years. That stability is exactly what gives us the regular seasons we take for granted. A second moon, depending on its size, orbit, and position relative to the first, could create conflicting gravitational forces instead of one steady pull. The likely result? Earth's axial tilt could become far less stable, shifting irregularly over thousands or millions of years, instead of the mild, predictable wobble we currently experience. That means irregular seasons over very long timescales. Regions could shift from mild to extreme climates over thousands of years in ways that would be nearly impossible to predict or biologically adapt to. At the most dangerous question in the entire video, 2 large orbits around the same planet aren't necessarily stable over the long term. The mutual gravitational pull between the 2 moons, combined with the gravity of Earth and the Sun, could cause both orbits to shift over time. In some scientifically modeled scenarios, the 2 moons could gradually drift closer to each other over millions of years until they reach a critical distance known as the Roche Limit, the point where tidal forces from the larger body start tearing the smaller one apart. If that happened, we could see a direct collision between the 2 moons, or one shattering into a debris ring around Earth, similar to, though far smaller than, Saturn's rings. Another possible outcome? Orbital instability could cause one moon to drift away entirely and escape Earth's gravity into space, leaving just a single moon behind. Meaning, even if we started with 2 moons, there's no guarantee that situation would last for millions of years. That the 2 moons did settle into relatively stable orbits for millions of years, a possible but less likely scenario compared to instability, the impact on the evolution of life on Earth could have been radically different. Some scientific theories link the emergence of early life in the oceans to strong tidal activity, which helped mix the chemical ingredients necessary for forming complex organic molecules. Stronger, more complex tides caused by two moons could have accelerated or completely altered the path of biological evolution from the very starting point. Additionally, species that evolved behaviors tied to moonlight, like the mass spawning events of certain coral reefs, timed to specific lunar phases, would have had to evolve completely differently around a far more complex lighting pattern. Here's the exciting part. This scenario isn't pure science fiction. Scientists have a credible theory that Earth may have actually had more than one moon in the very early stages of its history, following the giant impact that formed our current moon, and that a smaller second moon may have merged with the primary moon over millions of years instead of remaining separate. This could actually explain why the two hemispheres of our current moon are so geologically different from one another. In other words, the possibility of having two moons isn't as far-fetched as it seems. It's their long-term stability that was never guaranteed. The single, stable moon we have today, after billions of years of early instability and collisions, might actually be the final outcome of a far more complex story than a simple single moon. If you enjoyed this video, subscribe to the channel, and let me know in the comments, which space scenario should we explore next?